Hi, welcome to the Oracle Groundbreakers EMEA Virtual Tour 2020. Unfortunately, not a physical tour, very much a virtual tour. Let me just click on there. Hey, my name's Neil Chandler. I'm an independent database consultant. You'll see my Twitter handle and the website where I blog things and that sort of thing. I'm also an Oracle ACE director. All that means is I like giving talks. It doesn't make me an expert. Well, I'll let you decide whether I am or not. So, database statistics. Well, normally in this talk right now, I would show a video, but because this is on Zoom, it doesn't actually come across very well. So imagine we've all just watched a really funny video about Stats Wars or Star Wars a long time ago. So a long time ago, there was a thing called the rule-based optimizer. Now, it was deprecated in Oracle 10, but Oracle still use it themselves. And it didn't know anything about the shape of your data. And Oracle introduced the cost-based optimizer to replace it. What the rule-based optimizer used to do was it followed rules based upon how you coded your SQL and added in some heuristics or rules to determine things like the access paths. And it's probably source of the full table scan is bad myth. As in, if you look at the heuristics ranked from best to worst, the very worst one would be a full table scan. So people got the idea full table scans were bad. This isn't true. Full table scans can be the fastest, most appropriate way to access your data, depending upon what you're doing. But interestingly, Oracle still use the rule-based optimizer themselves. And this is pulled out of a 19C database recently, and we can see Oracle have got the rule hint in there. And it's quite a useful little tip. If you're working with the data dictionary and you're having a performance problem, just try putting the rule hint in for the data dictionary. The data dictionary was originally designed when there was only a rule-based optimizer. So it tends to work quite well with the rule hint. But I've also seen literally a few weeks ago, the rule hints still in applications in 2020 in Oracle 19.7 databases. And that's because if you use hints in your SQL, they're hard to remove. But interestingly, when I looked at the hint report, the optimizer was in fact ignoring the rule-based hint in those SQLs in the modern application, or rather the long-lived upgraded application. Anyway, enough of the rule-based optimizer. We're here to talk about the cost-based optimizer. And this slide, which is stolen from the 19C tuning guide, will tell you that what Oracle's doing is taking a parsed representation of your SQL statement and using statistics to work out in the optimizer the best way to access your data. And what it does is it generates multiple plans for different ways to access your data and compares them. And then it takes the plan with the lowest cost and executes it. And that's almost true. It's certainly true enough for this presentation. It isn't actually true, but it's usually true. There are times when it doesn't take the plan with the lowest cost, but that's for another talk. And so the question that I decided to ask her, what are these statistics anyway? Well, we have a lot of tables in the data dictionary which are holding statistics about our data. Now, I've no intention of going through them all, but I would like to go through just 4 important ones to try and explain a little bit about the data that Oracle is storing about your data. Now, this is dbastatps statistics, and of course, we're not going to go through all of that. It's far too big a slide, far too much information, and most of it is obvious and you don't need it. But what I would like to do is just pick a few key columns out from these tables and talk about them. So from dbastatps statistics, your dba table statistics, we've got the number of rows in there. And that's the number of rows in your object, in your table. And it shows the relative scale. When you're joining multiple tables together, it knows the big ones from the small ones. And that's useful. Likewise, the number of blocks in the table. Now, the number of blocks in the table is telling Oracle how much I/O it would need to do to read your entire table end to end. And I/O, that's basically time. That's basically your cost. We also have our last analyzed date, which was the last time we gathered statistics on your data. That's useful. And how big was the sample size in gathering the stats? And that's used perhaps a little bit more, which I'll show in some histogram information later. It also will tell us if the stats were actually entered manually rather than gathered by the stats jobs. And if the stats are locked, because if you lock the stats against a table or a partition, then they won't be gathered automatically and they won't change. And that can be a good thing and a bad thing. Hopefully we'll try and explain that. And then we've got stale stats. Are the stats old and need regathering? And this would normally happen when around 10% of your data is changed by default. And in 19C, we've got this column notes, and that's giving you some special information about some special properties of the stats and different notes for different types of stats. I'll hopefully talk about that a little bit later. But we're also holding information about each column within the table. And we're holding the number of distinct values in the column, which is useful. So if you know how many distinct values there are, you'll know what percentage of the data you're going to retrieve for any given predicate. We also, and this is very important to the Oracle Optimizer, holding the low value and the highest value in the column. And when we're doing queries, understanding the lowest value and the higher value and the number of distinct values will help Oracle work out how much of the data is going to be returned. And there's some special processing Oracle does with the low and high value. And it does a thing called statistical decay, which I'll hopefully try and explain here. It's easier said than done. Let's say we've got a date column and it's holding 15 dates from the 1st of April, the low value, to the 15th of April, the high value. Well, if we do a query where the date is, say, the 13th of April, which is in between the high and low value, we might get a cost of, let's just say 150, because it makes my arithmetic very easy to do. If we query outside of the high-low value, Oracle says there is an increasingly small chance that the data you are looking for is actually in the table. Therefore, it decides to reduce the cost by the distance of the high value minus the low value. So we get this linear decay of cost. And if we then query, for example, whereas the 20th of April, the cost is reduced by 1/3. And here, for the 25th, it's reduced again. And if we query above the 30th of April for query May, June, July, then the cost will be 1. And the same is true of the other end of the low value. And so what happens is you get this reducing cost. Well, it isn't actually cost. I'm kind of playing with terminology. The decay reduces the cardinality, the amount of expected rows coming back. But that's the major influence on cost, because it will make the optimizer wonder how much I/O it needs to do. And if you're reducing costs and these values are reducing, once they've reduced enough and they get down to a cost of 1, if for example, you've got several predicates which have reduced down to a cost of 1, how would Oracle understand the best way to access it? And that can be a bit of a problem. So having static stats or locked stats can cause you issues in this regard, or if you're not gathering your stats regularly enough. We also have the column density, which is 1 over the number of distinct values, which is the percentage of the table retrieved for any specific value. And that this column isn't used if we have a histogram on the column, which is worth knowing. We also have our sample size. If we have a histogram on the column, so it names the histogram, and the amount of buckets used by that histogram, if we have one. And I'll talk more about histograms in a moment. We've also got index statistics. We've got the number of rows, which is again the index scale. We have the number of leaf blocks, which is the amount of, effectively, the amount of blocks for the index, so therefore the amount of I/O, so the amount of I/O Oracle will need to do. We've got the number of distinct keys, which allows us to derive the percentage of the index that will be needed to be accessed for any given predicate. And then we've got a thing called the clustering factor. And the clustering factor tries to explain how aligned the index is to the table. I'll try and explain this in a little more detail. It's basically saying, can we reread the same table block for the next value that's in the index? And if the table block is within the last X number of table blocks that we've read, do not increase the clustering factor, where X is determined by a setting of table cached blocks. I'll explain that in a moment. And the default of this is 1. So what I'd like to do is try and show that via a diagram, show the clustering factor. So we've got here, we've got an index block where we've got rows 1, 2, 3, 4, 5, and we have quite a nicely aligned set of 2 table blocks, rows 1, 2, 3, 4, 5. So for our index block row 1, we access table block row 1. Our clustering factor is 1, we have accessed 1 table block. For row 2, we go to row 2, it's the same table block, so clustering factor is not incremented. 3 to 3, 4 to 4, 5 to 5. We've now moved to another table block, so the clustering factor is incremented because we've moved to a new table block. However, if we have the same sort of arrangement, but where our rows 1, 2, 3, 4, 5 in the index are laid out differently in the table blocks, they're not aligned, then what happened is our row 1 in the index goes to table block 1. Row 2 in the index, that's gone to a new table block. Increase the clustering factor. Clustering factor is 2. 3 has gone back to the original table block. And because our table cache blocks is set to 1 by default, we increment the clustering factor again. For row 4, we increment the clustering factor again. For row 5, we increment the clustering factor again. So because our index and data are misaligned, we get a clustering factor that's close to the number of rows in the table as opposed to the number of blocks in the table. And the clustering factor is very important when the optimizer is deciding whether an index should be used or not, and whether an index is any good. If the clustering factor is close to the amount of table blocks, it's thought of as a cheap index. And if the clustering factor is thought of is close to the number of table rows, it's thought of as an expensive index. And the clustering factor is as important to the optimizer as the entire size of the index. So you can see having a bad clustering factor will cause indexes not to be used. And if you rebuild the index, it doesn't change the clustering factor because it doesn't change the order of the table. In Oracle 12.1, Oracle realized that this could be a bit of a problem, especially in the scenario I've just showed where it's bouncing between 2 table blocks. And they introduced a preference called table cached blocks, which says, actually, I expect there to be this many blocks in the cache, therefore don't increment the clustering factor if the number of blocks is within the last, in this case, example I'm putting on here, 16. So this is probably a good place to start. My recommendation is you increase the table cache blocks in your global preferences to a higher number. And I wish Oracle would do this by default, but it can make your indexes seem a lot more realistic in terms of their cost, and it can help the optimizer choose indexes when it's more appropriate. And then we've got histograms. Histograms are additional statistics which try to describe the data distribution in a column. They're trying to make it much more accurate, so it knows for any given predicate a much closer value to the real value. And there is, from Oracle 12, 4 types of histogram. We have frequency histograms. Now they're really cheap to gather from 12. and they will appear on every single column in your table, which has got less than 254 distinct values, the number of distinct values, that is used in a predicate somewhere. Unless it's a primary not null key and it's only using equality predicates. But basically, you get lots of frequency histograms on your tables in 12. And that's because they're very accurate and they're very cheap to gather from Oracle 12. There's a new type of histogram called top frequency, which is mostly accurate, and it can be treated as a frequency histogram to all intents and purposes. They're very useful, and they're as good as frequency histograms in the main. We have height balanced histograms. Now, these are an old type of histogram where you have more than 254 distinct values in a column. It's not too much of a stretch to say they're mostly useless. They can cause plan stability issues, and they're only really of use where you have extremely skewed data. I'm not a fan of height balanced. Unfortunately, from Oracle 12, if you're using the defaults that estimate % of auto sample size for your statistic gathering, they are replaced by hybrid histograms. Now, hybrid histograms are still sampled. It's still sampling a percentage of your data to work out what they should look like. And that can cause some plan stability issues, but they are a notable improvement on height balanced histograms. And they should only be created on reasonably skewed data sets with more than 254 distinct values that appear in predicates by default. So it doesn't overload the amount of hybrids we have. You should be only getting them where we have skewed data. Although in my experience, most data is skewed. Before 12C, if you're still on 11 or 10, or then you still only have frequency and height balance histograms, and they are both sampled, which means they're subject to some plan stability issues. I'd like to describe histograms a bit, and it's quite hard to describe them just by talking about what the columns are. So I'd quite like just to show you a little bit of an example to show you what dbastatp histograms looks like. Now, using the sales table from the HR schema, we've got a column here, channel ID, which has got no histograms on it. And if we look in dbastatp histograms at this column, we discover that we do have a histogram, but it's a special type of histogram, and we've just got endpoint numbers 0 and 1, and it's just recording the high and low values in the histogram. So there is a histogram, but it's a very limited histogram, but it does show that Oracle really cares about your high and low values for the optimizer. The next column, promo ID, has a frequency histogram. And if we look at that, we can see in dbastatp histograms, we can see we've got, well, first of all, we need an assumed endpoint number of 0, so we've got somewhere to start. The first line is we've got an endpoint number of 2074 for value 33. So if we take 2074 away from, with minus the 0, the implied 0, we know we've got 2074 of value 33 in this column. If we look at the next line, endpoint 20,000 for value 350. So we've got 20,096 minus the 2074 from the previous line, gives us 18,000 of value 350. Likewise, for the remaining two buckets, we can see we've got 10,000 of 351 and nearly 900,000 of 999. And what that means is that when we put our predicates into our SQL, when we put our where clause in for this column where promo ID equals, Oracle can see that for the values 33, 350, and 351, that there's not very much data there. So therefore, it should be using the index to access that data. Whereas if we put in a value of 999, it can see it's gathering about 96% of the table. So a full table scan is a more efficient way of getting it. And so it's a very, very good user case for some quite skewed data for a frequency histogram. I'm not going to talk about height balanced histograms, move on to hybrid. And see, we've got hybrid, we've got 254 buckets, which is the default. We can increase that to a couple of thousand, but generally should be left at 254. And the way hybrid histograms are explained slightly different. We don't do the maths for hybrid histograms at all. We take the value, which is recorded against an endpoint, and we look at the endpoint repeat count. And what that's saying is we have 9 of value 6.4, 19 of value 7.1. So instead of doing the maths, working out against the endpoints, it knows exactly how many values that it found in its sample. And if we look at the rest of the values, all the optimizer needs to do is scale up this endpoint repeat count by the number of rows divided by the sample size that it's recorded to get the actual number of values in this particular column. So that's quite a useful way. And so what a hybrid histogram is, it's kind of a hybrid frequency histogram. It's not recording all values because it can't. But what it's doing is it's trying to record the popular values and be accurate with the popular values to put those into our optimization calculations. Okay, so hopefully that's useful. Some basic data that's being gathered. A couple of other bits of data that's being gathered. Oracle internal statistics. And we need to think carefully about when we're going to be doing this. So first of all, we have dictionary statistics. Now in Oracle 12 Plus, they get gathered automatically if we haven't gathered them. But I really don't recommend we allow this to happen. I would suggest that we gather them ourselves when we put our schemas in place. So you put all of your schemas in place and then you gather your dictionary stats. If you make a significant change to schemas or add new schemas, gather them again. It won't regather them automatically. It will only gather them if they don't exist automatically. And you must regather them before an upgrade and immediately after an upgrade. And that's the command to do it. And so once your schemas are in place, just run that command. It's done. It's a very quick command, nice and simple. The second set of internal stats are fixed object stats. And these are effectively stats against the $X tables. Now, what you need to do, now Oracle 12 Plus will gather them for you if they're missing, and that will be at the end of the normal maintenance window, but you don't want to allow it to do that. You need to gather these yourself during a representative workload. And so, for example, if you perhaps normally have 1,000 database connections, that would be recorded in table $KSUs, which is used by the view that we use $session. So we should be gathering our fixed object stats when we have all 1,000 connections against the database. So it's representative of what's going on in the middle of a workload, because that's when we're going to need our statistics most. So I really recommend that you wait until your system is fully up and running and gather your fixed object stats then. It also records information about the shape of the memory going on. So you make SGA changes or your workload significantly changes, you add a whole bunch of application servers, gather them again. I have a tendency to delete them before I gather them because of an old bug in Oracle 10, but you should be okay just doing a gathered fixed object stats. And the third set of Oracle internal statistics are system statistics, and they're designed to measure your CPU and storage capabilities. And one of the questions is, should we be gathering system statistics at all? And my reply to that is, heck no. In Oracle 10, Oracle said, gather them, absolutely gather them, they're wonderful. That's because they just invented them. In Oracle 11, they said, gather them, you must gather them. And in Oracle 12.2, the manual now says, don't gather them. Leave them as the default unless you really believe you need to gather these things. Most people I know don't really know quite how they work and quite what's going on underneath. And the biggest reason I can give for not gathering system stats is when Oracle's doing their testing and their regression testing, are they regression testing their optimizer against the default system statistics, or maybe the Exadata statistics, or are they doing it against the ones that you happen to have generated? They're doing it against the defaults. And the defaults are quite reasonable and quite good. There's only two sets of internal system statistics you should be setting, either the defaults, or if you have a pure data warehouse on an Exadata all on its own, and you really, really want table scans, you want to do a lot of offloading onto the storage cells, then do a gather system stats Exadata, because it really, really promotes the use of table scans. Otherwise, I'm happy to argue with anybody about why you shouldn't have them. Okay, enough system statistics. What about statistics on your tables? Well, this happens auto-magically every night in these windows. On Monday, it starts at 10 p.m. and it's got 4 hours. And every table which has got more than 10% change will have its statistics gathered, or every partition with more than 10% change, if you've got partitioning, will have its statistics gathered. Because I don't know about you, but generally speaking, most of my clients stop work at 10 p.m. and don't do anything for 4 hours, and they don't work at all at the weekends. 20-hour window at the weekends. It's not how modern systems work. But this is the defaults. This is the default. This is the default of what's going on. You also need to think, your statistics are being gathered at 10 p.m. Would 10 a.m. be better? Would that be more representative of the status of all of your work orders or trades or sales? Or at 10 p.m. when perhaps everything's been completed and is being shipped? And is your system really idle all weekend so you can just go off and gather stats with impunity? And also, can you actually gather all of your stats in 4 hours? Little real world example. This is a 12.2 system that was written possibly pre-10. And what was happening on this system and why I was there was at 7 p.m. they were doing a big data load. And at 8 p.m. they were gathering their system stats with some very, very specific entered information. So some very specific options, estimate %10 and the like. At 9 p.m. it was performing a data manipulation with these lovely new stats. And then at 10 p.m., whilst it's still doing the manipulation, the Autotask job kicked in and did a gather again, still dependent, with different default options, because the previous options were put in on the command line. Then at 4 a.m., they had another manual job after all of the data manipulation to regather stats again, and it had yet different input parameters yet again. Now, one thing this particular company had done has disabled the Autotask stats gathered several years previously, but they then upgraded their database and the Autotask had been re-enabled, and they didn't realize that, and it was causing them significant issues. And what I took away from this is, how can we go through and make sure that this particular, oh, by the way, this wasn't one single job, this was 200 overnight jobs. There was quite a lot of work and a lot of coding. So how do we ensure that we can always get the same gather on each table as it's loaded? How do we avoid repeating these gathers and gathers and gathers? And do I have to rewrite all of this batch code, 200 batch jobs, and all of the gathering of data in there with all of the retesting that will be needed? So how do we ensure it's always the same gather? Well, stop specifying options on the command line. With stats gathering in relation to each table, we should be using set table prefs. We should always be setting our table prefs to exactly how we want the stats to be gathered for that table, and we shouldn't use command line options. In that way, it's going to be consistent. Every time we gather stats for a particular object, we're going to gather them with the same preferences. How do we avoid repeating work? Well, in this particular case, we could either adjust the 10 p.m. window, disable the auto task, which I really don't recommend. But if you ever need to disable the auto task, you should actually be setting it to do Oracle stats gathering only. Or we could maybe, in this particular case, adjust the stale percentage of the stats so that table doesn't get regathered when we don't want that particular table to be regathered. And do I have to rewrite lots of my code? Well, from 12.2, there's a really nice table preference which says preference overrides parameter. And that means that your table preferences will override any command line parameter that's entered. So therefore, if someone puts a command line parameter in there, it is ignored. And you don't need to go and revisit your code. Any stats gathering is just done by reference to the table prefs and the global prefs. So that could be a worthwhile one just to commit to memory if you just happen to have the problem where you've got lots of code doing lots of gathers and you want to make it much more consistent. Looking at dbastatprefs, if you just do a query, it'll tell you what preferences you've set. This, for the estimate percent of 0.00000 actually means the auto stat size. It's the automatic default. It just happens to be what it looks like when you say it explicitly. We can also set preferences at a global level. So, for example, if at a global level we do not want to have any histograms, we would say for all columns size 1 by setting the global pref method opt. And therefore, the next time stats gather on, it would remove every single histogram in our system, except where we had them set for table prefs. Don't go to your system and do this. All of your plans will change. There's lots of global prefs and they're increasing in size. We had 12 of them in 11G and there's 14 new ones in 12, 18, 19. So more and more preferences coming along to allow us to control our stats better. So something that I come across a reasonable amount, stats not gathering. How many of you look at your DBA Autotask job history? And the answer to this can't be all of you, because I see this everywhere. 60–70% of large installations, I go on and they will have stats gathers, the status stopped, reason the associated window was closed. You couldn't gather your stats in the window available. And I see a lot. And it never fails to surprise me because the DBAs on site didn't know. You should be doing this on a regular basis, looking in your Autotask job history. So how can we fix that? Well, we can make the window bigger, but maybe we can't make it big enough, or that's just easy anyway, so it's a bit boring. So what we can do is we can try and speed up the stats gather. And we've got a couple of ways of trying to do this. First of all, for a particularly large table, we might want to parallelize it. So we can turn around, we can do a set table prefs for the schema, table X, degree 4. That table will now gather stats parallel 4. And it will be roughly 4 times faster, because by default, stats gathering is a table scan. So as long as you have the IO bandwidth, that should, and the CPU bandwidth, that will be 4 times faster. Cool. If you're brave, or stupid, if you're brave, you could just let Oracle auto-parallelize all of it. And you can set from the global prefs degree, dbastats auto degree, and it will throw all of the power of the machine at gathering your stats. You might not want to do that. You might be imposing upon your actual application, allowing it to do that. But there is a different option as well. We can also look to gather stats concurrently. And there's a fairly new preference, which is concurrent. And we can set that to automatic. So when the automatic stats gather happens, it will, instead of running a single job to gather stats in a linear fashion, it will actually batch tables together into lumps and run them all simultaneously. And you will get several scheduler jobs all starting at the same time. You'll have one job for one big table. You might have another job containing 50 small tables, and it will chop them up to try and get what it thinks is roughly them all to run across at exactly the same time frame. By default, that is switched off. If you are going to speed up your stats gathering, I highly recommend you use the resource manager to limit the resources consumed. There is an Autotask resource manager consumer group or a $Autotask. And although if you're doing any parallel processing at all, you should really use resource manager to control it. So one query can't take over the entire server's resources. And to do this with the Autotask, here's a resource manager plan that can just to show you how to do it. I'm not going to go through it because I haven't got time. Manually setting stats. Well, we can set stats ourselves. You set the stats, log the stats, bask in the glow of consistent plans forever. Except it's just not that easy. At one particular client where we did this, we spent a long time getting some really good calculation of what the stats should be, and we put it all in and it just didn't work. And it took quite a lot of experimentation over a number of weeks to get this absolutely locked down and left. And as it happens, they've not gathered stats on that since, and that was a good 6-7 years ago. But that's quite unusual. What I normally see is something like this, which is a real world example from another client a few years ago. And this is their actual code. They went in to do a set table stats. You know, we know better than the Autostats gather, we will set the table stats ourselves. And this is what was being set. It was saying the number of rows, the number of blocks, and the average row length. Now, the thing is, when it's doing that, is it setting everything that it should be setting based on what I've said today? Well, if we look in the dbastatps statistics for the table that was doing this, we've got a sample size of around 500 million, and we've got a number of rows of 2 billion. So there's a bit of a mismatch there. If we look in the column statistics for the overall table, we can see we've got a low value of around 10 million and a high value of around 1 billion, just under 1 billion. But if we look in a partition column statistics in one of the partitions, in just one of them, we had a low value of 10 million and a high value 4 times the size of what's in the global stats. That's because the global stats weren't being set. And the problem here is if you're doing queries being optimized and it runs against a single partition, it will use the partition statistics. And if it runs against more than one partition, it will use the global statistics. And you can get quite different plans based upon what's going on. The big risk with manually setting statistics is, did you set everything you need to set? And did the bits you missed matter? For this particular client, they didn't matter for about 4 years. And then they really mattered. And it all kind of fell apart and stopped working. Okay. Moving on. These aren't the stats we're looking at. I'm running out of time. These aren't the stats we're looking at. When your code runs, there is a thing called a statistics collector, which is gathering statistics whilst your SQL is executing, so it can see what's going on. And as your SQL executes, it gathers more statistics and puts them into memory. And if they're different enough, it will then feed those statistics back into the optimizer when re-optimization happens. You may also have a SQL plan directive if you're using adaptive statistics. And a SQL plan directive will do some dynamic sampling of data and store the results for that in a SQL plan directive, which it will use as well as the other stats that it has. So there's more stats going on than what I've talked about. The ones in memory from the statistics collector are in VDollar SQL plan statistics all. And if we look at them, what we've got here is, you can see the statistics collector in the plan, and we've got a cardinality here of 25, cardinality, how many rows the optimizer thinks is coming back, and an output rows of how many rows really came back, which is an awful lot more. We expected 25 rows, we got more, and they came back and it did a repass and you get a different plan. But this is only held in the SGA and does age out. I'm very, very out of time on this. Dynamic statistics, no matter what you're setting them to, are always a sample of what's going on. And if you're using parallel, will be used even if you're at the default level of 2. And if you've got a 10 billion row table, how representative of your data is a dynamic sample of 4,096 blocks, which will be a level 9, never mind 64 blocks? If you're looking for consistent plans, should you really be using any dynamic sampling? If you look in the notes section of dbMSX plan, you will see dynamic sampling being used, and the level it will use will depend upon how big the tables are when you're doing parallel queries. And you can actually see the queries running because they're just SQL. And if you look in v.SQL text for these two particular comments, they will show you the dynamic sampling taking part. Now, adaptive statistics were introduced in 12.1 and then disabled by default in 12.2 because for OLTP and for many scenarios, they're not really very useful because what they don't provide is good stability. What they do provide is a good ability for the optimizer to improve itself where you've got queries which you want to get exactly right. You know, where you've got big data warehouse queries and they can really help with big data warehouses. But for OLTP, you really don't want adaptive statistics running. If you look in the dynamic SQL plan directives, you get the dynamic sampling and dynamic sampling result. I have to skip back through this. And you can see here we've got dynamic sampling results for customers' city. And this is information that is being gathered dynamically about customers' city and will age out and be regathered from 12.2 with your normal statistics aging out. In 12.2, there's an entirely new feature, and it's called the Statistics Advisor. Now, it runs nightly if there's time left in the overnight stats window, or you can run it yourself. And this is the code that you can use to run it. You create an advisor task, execute the advisor task, and report the advisor task. And if you are extremely brave, you can implement the advisor tasks without any questions. Off you go, and it's there. And it will put in all of the report recommendations. I really don't recommend you do this. But what's it recommending? What's it giving us? Well, it gives us a nice big report telling us what's going on. So, for example, here we get a findings, which it says use concurrent preference for statistics collection. And it's basically telling us to do a set concurrent all. So when we gather statistics, it will do it concurrently. And so I find it interesting that it makes that recommendation, but that's not the default. But it will always make this recommendation for you. And then it gives you some rationale about why you should be doing that. Using concurrent increases the efficiency of stats gathering, which may or may not be true depending upon your scenario. Another one, use default preference. It's noticed that I've changed the method opt on the global preference to for all columns size 1. And it's basically telling me, you've changed this. You should be using the defaults because obviously we know best, that's why they're the defaults. And it gives you the rationale behind it. So it gives you lots and lots of information. Now, I'm probably fully aware that I've set that preference. So one thing you can do with the statistics advisor is put some rules in place to say, don't show me that one. I already know about it. And there's a whole series of rules that you could configure to say, I understand this preference, I understand that preference, don't show those to me, please. So you can keep running this on a regular basis, and it will give you some quite reasonable advice. It links to things like really good blog posts. I'm just about out of time. A couple of really new, extraordinarily cool features that are Exadata and cloud only, which annoys me because they're really cool features, especially real-time statistics. But unfortunately not available on-prem, even for Enterprise Edition. You've got to be on Exadata. If you've got an Oracle ODA, sorry, no good. What real-time statistics does is it samples data going through the statistics collector, and it tries to spot what's going on. So if it sees a low value that's lower than the normal ordinary low value for a column, a high value that's higher, or it sees DML that's changing the number of rows, it will dynamically change these statistics in the database. What this does is the high-low threat that I showed you at the start of this, it gets rid of it. It's gone. It reduces that risk significantly. Now it works in memory, and it does a roughly 1% sample. So it's catching about 1% of the data to minimize the impact, but it really does work, and it really does minimize it. But unfortunately, you've got to be in the cloud or an Exadata to have this working. You see there's a dbastatps statistics notes, which will tell you in dbastatps called statistics, stats on conventional DML, which means that you get an extra row per column, and it tells you that things have changed in that column, and it's recording real-time stats. You still need to do your normal stats gather. It's not gathering everything. It's not doing distinct values and that sort of thing, but it is picking off some of the low-hanging fruit and making your life much better. It's really good stuff. And the high-frequency optimized stats is basically doing a gather stale much more frequently. And it's trying to identify it. So where you've got a rapidly changing data, it's trying to capture that in a particular table. And it's just trying to do gather stale. Again, doesn't replace the auto task. It doesn't run during the auto task window. And we've got some new global prefs associated with high frequency statistics gathering. And you can see where that's running as well in that table there, DBA Autostats executions. What didn't I cover, since I'm over time? Loads of stuff that I didn't cover. So hassle your user group if you'd like me to come back and actually cover some of these things on here, which I can cover in other talks, but 45 minutes, 50 minutes, not really very long. So that's about all I've got time for. Is there any questions there? Do I have time to take questions, Marilla?
Yes, if you answer quick. Now you have around 5 minutes.
Cool. Question one, we have tried to speed up statistics gather process with concurrency, but we have run on events from concurrency class. Do you have any comments on that? By that, I presume you mean that you're having problems with the concurrency, or because it's whenever I've used concurrent, it's tended to batch things up in a reasonably sensible way. So I would wonder, are you out of resources associated with it? Maybe. It's quite a difficult one to answer without more details. And I see the same person's also asking, do you have any experience with incremental statistics? Yes, lots. They can be problematic. It's entirely dependent upon which release you're on. Prior to 12, they can take huge amounts of space in sysorgs. In Oracle 12, they've really changed how they store the synopses for incremental statistics for the distinct values, and they only take about 3 to 5% of what they used to take. So where it used to take vast amounts of space, it really now takes quite large amounts of space to store the incremental stats. There can be a bit of a minefield. I do know sites where we've just had to bite the bullet and turn them off. Probably 19.7. I've just done incremental stats. We with one particular company where we did have some problems with the statistics, which I've yet to raise with Oracle. Actually, it's that recent. Did have some problems with the statistics being ignored when we're doing incremental stats, and being slightly problematic. Incremental isn't necessarily a panacea, unfortunately. Ideally, when they work, they're great. There can be a lot less work for stats gathering because you only gather for stale partitions. But they can be slightly problematic, especially if you have very wide tables. Bo says, do I recommend locking statistics on the table to avoid frequent collection and do it with forces necessary? No. Not as a matter of course. Generally speaking, if your stats are stale, it's only going to gather them when they're stale anyway, and that's when they should be gathered, because that's when they're getting it. You might want to adjust the stale percent on a table by table basis. Also, you need to be careful if you're looking stats, especially on a partitioned table, because if you look the statistics on a partitioned table, you can actually end up causing significant problems, and your incremental stats gathers can stop working. And it has to revert back to gathering everything. There's some interesting new options that I'm out of time for that I can't really answer on this. My email address is there. If you want to ping me a question on my email address or tweet me, I am more than happy to try and pick up and answer those questions afterwards. But I think I'd better stop before Morella gets annoyed at me. So
I did something. I just copied the question from Q&A and I sent it to you, Neil. And yeah, maybe you can have a look and tweet the answer if that's okay with you.
Absolutely. And I can always try and tweet the answer out if we can make it down to 240 characters or maybe a small chain. That would work quite well.
Well, then you can write an article and just answering the question if it's so long. So thank you so much. We have to stop now to give room to the next session. Thanks a lot, Neil. It was very interesting looking at the number of attendees and the number of questions. Very interesting subject. See you in the next session or somewhere around.
Thanks very much, everyone. Bye-bye.